We've covered how we can identify significant figures. We have also looked at how we report the correct number of significant figures when taking measurements. And often with those measurements, we want to do some sort of calculation. And so we need to know how to properly handle our significant figures in a calculation. And so first we'll look at addition and subtraction. So in addition or subtraction, the result, the answer, carries the same number of decimal places as the quantity with the fewest decimal places. And that's easy enough if all the numbers in your question, in your calculation, have a decimal place, like in this first one. And so you can line them all up vertically, like in this first example here. And then you are going to report your answer to the decimal place that is the least certain. So if we were to add up all these numbers here, we would get 13.096. Okay. And you can see the first number has four significant figures. The first number has four significant figures, that's true, and 3 decimal places. It reports the precision to the tenths, hundredths, thousandths place. The second number has 2 decimal places, so it reports the number out to the hundredths place. That's the level of how precise it is. This third number reports out to the tenths place, to our first decimal place, and the last one reports out again to the thousandths place. So since this one has the least number of decimals, it only has 1 decimal place, our answer can only have 1 decimal place. So we'll have to cut off here. But whenever we're going to cut off, we want to take into consideration the part we're cutting off. That's a significant part. So if we look at that number and it's greater than 5, in this case it is, then we need to round up that last digit. So 13.096 becomes 13.1. And that's the correct way to report your answer here. Now, what happens if your question or your calculation doesn't all have a decimal place? So another way to say this is that your answer should have the same level of precision as the quantities in your calculation. For instance, this top number, 8,000, well, we don't know if that's 7,945 or is it 8,012. We know it's 8,000. There's no decimal point here to really let us know that these zeros are significant. So we only have precision here to the thousandths place. Thousands, no TH at the end, okay? Here, the 354, this reports to the ones place. Here we have a very precise number. It's reporting out to the hundredths place. And then on our fourth number here, it is precise to the tens place, okay? So we are really limited by this top number. It's only precise to the thousands place. So when we add up all those numbers, we get 19,474.58. Since we are limited by this 8,000, we can only report our answer to the thousands place. So we are going to have to cut off here. Okay. Since the number after our cutoff point is less than 5, we can leave the number as it is, and we would report this number as 19,000. So that's how that works there. Let's look at some more examples. In our third example here, we have a subtraction problem. Our first number is reporting out to 3 decimal places to the thousandths place. Our second number is reporting 2 decimal places to the hundredths place. Again, since they both have decimal places, it's pretty straightforward. This one has 2 decimal places, this one has 3. You go with the least number, only 2, so your answer should only have 2. So if you subtract these two, you end up with 0.892. Again, we can only have 2 decimal points. So if we see there, we have a 2 after our cutoff point, and therefore we don't have to round. We can just report our answer as 0.89. All right, on our next problem, again, we have that same problem where all our numbers don't have decimal places. The bottom one, the 98.87, has 2 decimal places, but the other 3 numbers have none. So we have to look at their level of precision. The top number reports to the thousands place. Okay, there's nothing reported for the hundreds, tens, or ones. And there's no decimal point to tell us that these are significant. So all we know is that it's precise to the thousands place. The 2,345, that's precise to the ones place, and the 767 is precise also to the ones place. So we could add up all these numbers. We would get 68,210.87. But we are limited by the 65,000, so we got to cut off at the thousands place. We look at the number after our cutoff point is 2, so again it's below 5. So we report our answer here just as 68,000, and of course, dollars. And then the last one, they all have decimal places. So this has 3 decimal places, this has 1 decimal place, the bottom number has 2 decimal places, so we're just limited by that 1 decimal place. So we can add them all up. We get 32.133, and we're limited by 1 decimal place, so we would cut off here. Again, the number after the cutoff point is 3, that's less than 5, so we would report this as 32.1. And of course, we want to make sure we include our units since it was given in the question. So 32.1 meters, very important. Okay, so that's for addition and subtraction. Of course, the other type of calculations we might be doing are multiplication and division. And this one, I think, is a little more straightforward than the addition and subtraction. So in this case, the result, or the answer, is going to have the same number of significant figures as the factors in the calculation. And it's going to have it as the factor with the fewest number of significant figures in the calculation. And there's a point here, it says don't include exact numbers or conversion factors. And we will see as we go through these calculations what an exact number is and what a conversion factor is and how we handle those things. So for this first one, 9.4 times 4.34 times 2.000 times 0.002. So if you do that calculation and if let's say you plug that in your calculator, and I know everyone's usually eager to put in all the numbers, so you get 0.1633184. Okay. But we have to look at our number of significant figures. So the 9.4 has 2 significant figures, 4.34 has 3 significant figures, 2.000 has 4 significant figures, and this number 0.002 only has 1 significant figure. Remember, these leading zeros are not significant, so it only has 1. So we're limited by this factor in our calculation. With only 1 sig fig, that means our answer can only have 1 sig fig. So we'd have to cut off here, and the number after our cutoff point is a 6. It's greater than 5, so that means we round up. So this becomes 0.2. All right, let's look at our next problem. 93,200 divided by 3.24, and that answer divided by 3,232. Again, if we do this calculation, we would get a number 8.900195575. Okay. We need to go through and figure out the sig figs of each factor in our calculation. So this 93,200 has 3 significant figures, 3.24 also has 3 significant figures, and 3,232 has 4 significant figures. And so we are limited by our 3 significant figures. So 1, 2, 3. We got a cutoff here. The number after our cutoff point is a 0. Okay. So we don't have to round up. We could leave it as it is. So this becomes 8.90 would be the correct answer there. Okay. In this problem here, where we have $12,000 divided by 3 people, okay? So in this case, well, if we do the math, 12,000 divided by 3, that gives us $4,000. There's a couple issues with this question. So if we consider our significant figures, the 12,000 has 2 significant figures. And at first you might say the 3 people only has 1, but this is something we consider an exact number. So the 3 people is an exact number. Again, we don't have to include those in our calculations when we're considering the amount of significant figures. So we're not limited by the 3 people. What we're limited by is the 12,000, which is precise to the thousands place. It has 2 significant figures. And so we can only have 2 significant figures in our answer. Now, our answer 4,000 kind of presents us with this weird dilemma here. And the best way for me to solve it is to put it into scientific notation. And what I mean by that is, like, right now at 4,000, it looks like we only have 1 significant figure. We don't know if the zeros are significant or not. So, but we should have 2. And so if we change this to 4.0 times 10 to the third, then we are giving the answer with 2 significant figures. And it's the same meaning. So a good way to kind of get rid of any ambiguity is to change your numbers to scientific notation, because the numbers reported in scientific notation are all significant. Okay. Looking at this problem, bottom left, 3.1110 times 0.0234 times 6.21 times 10 to the negative fourth, you get 4.5207 times 10 to the negative fifth. Okay. So again, if we look at our numbers here, we have 5 significant figures in the first factor. We have 3 significant figures in the middle factor and 3 significant figures in this last one. So we can only have 3 significant figures in our answer. So 4.52, we'd have to cut off here. The number after our cutoff point is 0, less than 5. So then our answer becomes 4.52 times 10 to the negative fifth. Looking at this next question, 8,000 times 0.0234 times 45, you get 8,424. Now this is a funny one because you're limited by the 1 significant figure in your 8,000, right? That's 1 significant figure here, 3 here, and 2 here, but we can only have 1. And so our cutoff point is after our first significant figure. The number after our cutoff point is 4, less than 5. So our answer becomes simply 8,000. What I say is kind of weird because we have 8,000 in the calculation. But if we're reporting significant figures, that's how we would report it. And then the last one, here's where that idea of a conversion factor comes in. Here we're taking 3.14 meters and we want to convert it to decimeters with this calculation. So we're using this conversion factor, which came from an inequality, right? Telling us that there are 10 decimeters in 1 meter. And so if we carry out this calculation, 3.14 times 10, we get 31.4 meters, of course. Always keep track of your units, very important. Oh, I'm sorry. That'd be 31.4 decimeters. Okay, meters cancel out here and there. Okay, and if we go back and we look, we see that this has 3 significant figures, the 3.14, and our conversion factor, it only has 1 significant figure. And so you may feel like, oh, I gotta get this down to 1 significant figure. But again, this is a conversion factor, and like we said, you don't have to include that when you are considering the significant figures in your calculations. So we don't have to take this conversion factor into consideration. So we can simply leave our answer as 31.4 decimeters. Okay, let's do some practice.